Hello students and friends. In this video I am going to discuss some multiple choice questions which pertain to the topics of introduction to organic chemistry, and I have taken this from the CAIE syllabus, particularly the AS paper 1, and these are some of the objective type questions from the organic chemistry section, and particularly questions pertaining to chiral centers and isomerism. I'm just going to discuss 5 multiple choice questions to make this video short. So the first question is that the diagram shows the structure of vitamin A, and as you can see, this is the structure of vitamin A, and in this, how many chiral centers are present in the molecule? So to understand the number of chiral centers, I expect that you already know that the chiral center is that carbon which is attached to 4 different atoms or groups. So it is very beneficial to display the hydrogen atoms which are not visible. So since these are 2 bonds here, so there will be 2 hydrogen atoms. Similarly here there will be 2 hydrogen atoms and 2 hydrogen atoms. At this point 1, 2, 3, 4, so no hydrogen atoms here, also no hydrogen atoms, and here also no hydrogen atoms. Here if you see 1, 2, 3, so there is 1 hydrogen atom, there is 1 hydrogen atom, and 1 hydrogen atom here, 1, 2, 3, 1 hydrogen atom here, and 1 hydrogen atom here, and 1, 2, 3, 1 hydrogen atom here, and 2 hydrogen atoms here. Okay, so you have to understand that where there is a double bond, that carbon can never be a chiral center because it will not have 4 bonds attached with it. So none of these double bonded carbons can be the chiral centers, but the other ones, they have 2 hydrogens, so they will also not be the chiral centers. 2 methyl groups, also not a chiral center. All the doubly bonded carbons are also not chiral centers. Here once again there are 2 hydrogens, so once again it's not a chiral center. So apparently in vitamin A, if you see carefully, there is not a single carbon atom which is joined to 4 different groups. So I think the correct answer is that there are absolutely no chiral centers in a molecule of vitamin A. Hope you understood this. And now let's go to the next question. The compound rotondone is responsible for the peppery smell of pepper and is also found in some red wines, and this is the structure of rotondone, and you have to find out how many hydrogen atoms are there in this molecule. So as I said, that it is beneficial to sketch out the hydrogen atoms which are not visible. So when you see 2 bonds, that means there are 2 hydrogen atoms. Similarly here 1, 2, 3, so there is 1 hydrogen atom, and because this is a carbon, so there are 3 hydrogen atoms. Now here 1, 2, 3, 4, 1, 2, so there are no hydrogen atoms here. 1, 2, 3, so there is 1 hydrogen atom here, but there is C, so there are 3 hydrogen atoms here. There are 2 hydrogen atoms here. Similarly there are 2 hydrogen atoms here. 1, 2, 3, so there is 1 hydrogen atom here. 1, 2, so there are 2 hydrogen atoms here. So there is a carbon, so there are 3 hydrogen atoms. 1, 2, so there are 2 hydrogen atoms. So now if you count the hydrogen atoms now, let's count from here. 1 and 3, 4, 5, 6, and 9, 10, 11, 12, 13, 14, 15, 16, 17, 20 and 2, 22. Well, I think I should make the counting again if I have missed out any of the hydrogen atoms. 1, 2, 1, 3, here 4, 4, 2, 1, 2, 3, 2, 2, 1, 3. So let me count again starting from here. Okay, so 1 and 3, 4, 5, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 3, 22. I think I'm missing out on some hydrogens because I found that the answer was 24. So which hydrogens am I missing out? 1, 2, 3, 4, 1, 2, 3, 4, 3, 1, 1, 2, 1, 2, 1, 2, 3, 4, 1, 3. Okay, I don't seem to be missing out, so let me count it again. 1, 3, 4, 5, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 3, 20 and 2, 22. So I think this is the correct answer, 22. Okay, so let's go on to the next question. The drug cortisone has this formula: in addition to those chiral centers marked by an asterisk, how many other chiral centers are present in the cortisone molecule? So as before, we will try to see which are the undisplayed hydrogen atoms, so that will help us to understand the chiral centers. So there are 2 over here, so this is not a chiral center. There are 2 hydrogens over here, so this is also not a chiral center. This is a methyl group over here, right? And so if you look at this particular carbon, then it is joined with a methyl group. This group is different, this group is different, and this group is different. So this is a chiral center in addition. And similarly here there are 2 hydrogens, so this is not a chiral center. 2 hydrogens, not a chiral center. 2 hydrogens, not a chiral center. Okay, so if you look at this carbon over here, then you have a methyl group over here, and then the other groups around this carbon are all different. So this is also a chiral center, this is a chiral center, and if you look at this, then also we find that this group is different, this group is different, this group is different, and this group is different. So this is also a chiral center, 1, 2 and 3. So there are 3 more chiral centers, and I think this is the correct answer. Okay, so now we go on to the next question, and it is that geraniol and linalool are compounds found in some flower fragrances, and you see these are the 2 structures, and what kind of isomerism is exhibited by these isomers? Is it chain, is it geometrical, is it optical, or is it positional? For chain isomerism, there should be a difference in the carbon chain, but there doesn't appear to be any difference in the carbon chain. So are there geometrical isomers? For geometrical isomers, the carbon bonded by double bond, cannot have 2 identical groups, so this violates the rule. And here if you see, in this case again, this there are 2 hydrogens attached to the carbon joined by the double bond, so that rules out the possibility of geometrical isomers. cis trans. And then if you look at optical isomerism, then there must be a chiral carbon. So there is no chiral carbon in this. As you can closely observe that there is not a single carbon which is joined with 4 different groups. So actually if you see, and then there are not mirror images, right? They are not mirror images. So this is CH2OH, and here the OH has been displaced, so it is not a mirror image, so they cannot be optical isomers. So only thing is that the position of the OH group has been changed from this carbon to this carbon, which means that they are positional isomers of each other, and then that is the correct answer. Okay, going to the last question, that is, what is the name of this compound X? So in this you have to understand that the OH group is given priority over the double bond, and therefore the numbering should start from here. This is the first carbon, this is the second carbon, this is the third, the fourth, the fifth, and the sixth. And if you look at the hydrogen atoms, then you have a hydrogen atom here, and then you have a hydrogen atom here, which obviously shows a trans arrangement, and the hydroxy group is attached to the second carbon, and there are 6 carbons, hex, and the double bond is between the 3 and the 4 position. So taking the lower number 3, this is the correct answer. So hope you understood how we can tackle these objective type of multiple choice questions which are based on the introduction to organic chemistry. And if you like the video, please give it a like and share it with your friends. Thanks a lot for watching.